Good evening, everybody. Today's session, we are going to cover module 2. And in module 2, we are going to cover virtualization. What is Azure Virtual Network? What is Azure Virtual Machine? Okay. So in the data center, in yesterday's, we used to have physical hardware. And on top of that, you used to have operating system and database and application, right? But now with virtualization, there's something called hypervisor. So on top of that, you have virtual machines. So basically the hardware will be evenly distributed or shared across the virtual machines. So it helps you in more scalable, agile solutions. And the whole cloud infrastructure is based on this virtualization, that is virtual network, virtual machine. Um, so, and that also provides different high availability options, right? So continuing from module 1, in today's session, we are going to discuss about IP addressing and how IP addressing is designed by cloud solution architect. What is the role of calculating IP address by a cloud solution architect, and uh, so VNET is the backbone of Azure. So on top of that, you have storage, and on top of that, you have VM. So we'll be continuing those things. If you remember the CIDR cheat sheet, right? As the number of subnet mask, right, increases, the number of hosts decreases. And for example, if you go for 27, which you use for Bastion, there is only 30 hosts, 30 minus 4, right? 4 is the reserve. So, but if you go for 16, there is 65,534 hosts, right? So we will see how you can calculate this exact number based on the subnet mask, or if you give number of, if the customer, you talk to the customer and the customer says, hey, I want this many subnets, and each subnet I want this many IP addresses. So you have to design the VNet and the subnet based on the customer requirement, right? So let's see how that is possible. In the CIDR address range calculation, IPV4 addressing, each of the digit in the IP address represents an octet in binary. So what does this statement mean? It means, let's say you have a 10.0.0.0 by 24, right? 24 is a subnet mask, right? So each number in this 10 represents an octet. So 10 in an octet means that many. If you convert it into binary, how you can convert it into binary? So first of all, this from left to right, if you see, the masking starts from left. Okay, if you say 24, that is 8 into 3. So the first 3 digits are masked. That means they will remain unchanged. So the remaining 1, 2, 3, 4, 5, that is remaining 5 digits can change. That is what 24 means. Okay, so now each of these digits carry a number 1, 2, 4, 8, 16, 32, 64, and 128. So for example, the number 50, if you say number 50, I have to add 32 plus 16 plus 2. 32 plus 16 plus 2 is 50. So if you see in there 0, 0, 1, 1, 0, 0, 1, 0 in binary means it is a 50. So you should know how to convert a number into binary. Same way, 75. 75 means 64 plus 8 plus 2 plus 1. 64 plus 8 plus 2 plus 1 is 75, right? So if you see 1 plus 2 is 3, and then 4 plus 8, this 1 plus 2 plus 4 plus 8 is 15. So it adds up. 1 plus 2 plus 4 plus 8 plus 16 is equal to 31. So 1 plus 2 plus 4 plus 8 plus 16 plus 32 is equal to 63. And then 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 is 127. And if you add all of these, it has come to 255, right? So if 255 means all the digits are 1, so nothing is a mask. Okay. So now calculate range from CIDR notation. So now if um, the customer, for example, you get this question, calculate range from CIDR rotation. So we have a set of exercises. Once you do this, you might have to write this down with a pen and paper and, calculate each of that. How do you calculate range? 10.0.0.0 by 24 means first three zeros are masked. So 8 plus 8 plus 8 plus, so the fourth octet is 255, right? So the fourth octet is 255. So the range is 10 plus 0, 10.0.0.255, right? So fourth octet is changed. Now let's see this one, 10.0.0.0 by 16. Subnet mask is 8 plus 8, so the first two octets will not change and the last two will change, right? So the last two is 255 and 255. So the higher the number, more the masking. The lower the number, less the masking. So I hope it's clear in the first two examples how you calculate the range from the CIDR notation. Let's see the third one, 10.0.0.0 by 20. So the subnet mask is 8 plus 8 plus 4. So the first two digits won't change. Third digit, only 4 is changed. So 4 is, if you calculate with this notation, it is 00001111. That stands to 1 plus 2 plus 4 plus 8 is 15. So the third digit is 15 and the fourth is 255. So you have to first see how many digits are masked, and the digit which is not masked, what is the calculation you have to do for that. And if you don't get this in the first time, don't worry, write it down and do it like 2-3 times, then it is getting clear. Okay. So then our fourth question, 10.0.0.0 by 13. The subnet mask is 8 plus 5 for second octet. That is second octet is 5. So you 00000. The first 5 is masked, and then the remaining 3 will change. So that is 1 plus 2 plus 4 is 7. So the second digit will change for 10.7.255.255. So the lower the number, higher the IP addresses. If you see here, the second octet is changing. So second octet is changing, and the binary calculation shows that the first 5 digits are masked and the remaining 3 is 7, right? So it's 10.7. So the range for this is 10.7.255 for 255. Let's see the next one, 192.168 0.0 by 18. Okay, so in this case, 8 plus 8 plus 2, the third octet, right? So the first two is masked and the remaining six is changing. The remaining six is 1 plus 2 plus 4 plus 8 plus 16 plus 32, that is 63. So the third octet can change for 63. So the number of IP address allowed here is 63 into 255. Okay, so we'll see that also, how to calculate the number of IP address. First thing is you understand how to calculate the range from the CIDR. So in this one, 172.16.0.0 by 27. Subnet mask is 8 plus 8 plus 8 plus 3. So the fourth octet, the first three digits are masked. The remaining 5 is 1, that is 31. So the fourth octet has 31. So 27 is range is 0 to 31. So if you have 4 reserved IP address, then only 27 services or resources can be created. Now let's see this one, 172.16.64.0 by 22. So 8 plus 8 plus 6 is 22. So the third octet is first 6 digit is masked. So last 2 is 3. So you have to add 3 to the third number. So from 172.16.64.0 to 172.16.67, and fourth octet is 255. So now let's see this one, 192, 168, 172, 128 by 28. So if you calculate, 28 is 8 plus 8 plus 8 plus 4. So the fourth octet will change, and the fourth octet, the first 4 digits are masked. The last 4 is going to change to 15. So if you add 128 to plus 15 is 143. So only the fourth octet is changing. So let's see, 192.168.0.0 by 23. Subnet mask 8 plus 8 plus 7 for third octet. 7 digits, only 1 is changing. So 23 means for the third octet 1 and then 255. The total IP address is 256 into 2. And then here we have one more exercise. Divide this network into 32 subnet with 16 IP each. Write first 3 and the last subnet range. So here 8 plus 8 plus 8 plus 4, the fourth octet is changing. So it is 15, 192. So the subnet mask is for each of these you have a subnet mask, right? So for this one, the first one, the subnet mask is 192.168.0.0 by 15 would be the subnet mask. And then 192, the each network into 32 subnets with 16 IPs each. So you have to divide 16 IPs 0 to 15, and then 16 to 31, 32 to 47, like that, and the last one will be 240 to 255. So once you get the total IPs, you can divide by 32. So then you can calculate the total subnets. So if you see 32 subnets, here you will have also one, the last digit will change, right? Second last digit. So 0 to 255, and then it will start with 1 to 1.15, then 1.16 to 1.31, like that. So you see total 32 subnets you can make. Now let's see this one. If for this network 172.16.12.80 by 23, find range total IP, divide this network into 8 subnets. So first let's find the range. Range for this is 23, 8 plus 8 plus 7 is 23. That means third octet is changing. So last digit is not changing, so only one. So you add 1 to the third octet, that is 129, and then 255. So this is the range. So now total IPs is 256 into 2, that is 5112, and you divide 8 subnets. So 512 by 8 divided by 8 subnets. So each subnet will have 64. 64 into 8 is 512, right? This is how you calculate. Just like the previous one, here you have 128. The third octet will change to 128 and 129. So now this is another exercise here for the network 10.0.0.0 by 24. Find range 10.0.0.0 to 10.0.0.255. Total IPs is 256, and divide the network into 8 subnets with 16 or 32 IPs each. So if you say 16, it will change to 16. If you say 32, it will change to 32. The subnet mask for 16 is 28. Subnet mask for 32 is 27, right? And then you can also calculate 2 exponent to 4, 2 to the power of 4 is 16. Okay, so n is equal to 4. In this case, 2 to the power of 3 is 8. So n equal to 3. So 8 into 32 IPs, here 16 into 16 IPs. So for this range, so you have to see how you calculate, then you can sit down and exercise, do this exercise. There are totally 15 or 16 questions here. So you practice this, I think then you are good. Okay. So there's 5 more, and then we go into practicals. We'll start creating some VNets and subnets, and then we'll create some VM and install IIS and do some practicals, even create some storage today. For this network 192.168.0.0 by 23, find range total IP divided into 32 subnets with 16 IPs. The first thing is range. So 23 is third IP will have 8 plus 8 plus 7, so only one is remaining. So the third IP will change. Third octet is changing to 1, and the fourth is 255. Total IPs is 512. So if you divide, if you calculate the subnets, 2 to the power of n equal to 32, right? So n equal to 5. So if you add the 5 to this 23, it comes to 28. So the subnet will be 192.168.0.0 by 28. Okay, here it will be 192.168.0.16 by 28. So by this time, you know how to calculate a range from a CIDR notation. So this one will be 192.168.0 by 0.16 by 28. So you can write a CIDR for each of the subnet. For this network 192.16.128.0 by 23, find range total IP, divide into 8 subnets into 64 IPs. So first let's find the range. Range is 8 plus 8 plus 7 is 23. So the third octet is changing, and so it is adding 1, and the fourth is, so the total is 512 IPs. 2 to the power of n is 8. So if you calculate the last third octet is changing, so 63, 127, 191, and 255. So same way, 63, 127, 191, 255 for these. So we are dividing it into 8 subnets, 64 IPs each. Now next is for the network 192.173.70.32.0 by 22, 8 plus 8 plus 6. So the third octet is changing 3, adding to 3, and divide 32 subnets means 1024 by 32, n is equal to 5. So you add 5 to 22, so it becomes 27 subnets. So for the network 14th one, for the network 172.16.240.0 by 25, find range total IPs, divide into 64 subnets into 4 IPs each. So this is a small network. So 25 means 8 plus 8 plus 8 plus 8 plus 8 plus 1. So n is equal to 6. So you add 6, so 31. So the subnet will be 172.16.240.0 by 31. So that's how you divide into 4 IPs each, 64 subnets. One more is for the network 10, 20, 30, 192 by 26. Find the range. Range will be 8 plus 8 plus 8 plus 2. The fourth octet change. So 63. So add 63. 192 plus 63 is 255. So only fourth octet range is that one. So total IPs is 64, and divide into 4 subnets, 16 IP each. So now let's create, after that, we are going to create a storage and try to see a SAS token, and we are going to create see how a public IP and private IP address is there in a virtual network. So let's try to create some VNet and subnet. So VNet has to be in a resource group. So we are going to create a resource group as well. Um, so I'll create a resource group called test RG. That's my resource group. And I'm going to create VNet called test VNet, and I'll create it in East US. So first, let's see what IP address it is giving. By default, it is giving 10.0.0 by 16, right? That is my VNet IP address. So subnet, I want to create 10.0.0 by 24. That is fine. I'll have two subnets. One is called the front end subnet. Let's delete the default, add a new front end. Ten point zero point zero point 24. They have to give a 1 year. That is fine, right? I had one more backend subnet. This one I'll say 10.0.2.0 by 22. So each of the subnet you are allowed 251 instance, right? Resources. So you can create like this subnets under the main VNet, right? So by default, Bastion host I disable DDoS protection, I disable firewall, I disable. Then I'll just review and create. Here it says that I have a address space 10.0.0.16. Front end and back end is let's create. So once the VNet gets created and the subnet gets created, then we can go and create our virtual machine, right? So and once the virtual machines are created, you can add a load balancer, you can add an application gateway, you can add a bastion, all that makes a network, and then you can create the deployment is done. So all this is a virtual network. If in the data center you have physical network, by cloud, everything is virtual, right? So test VNet, there's two subnets here with 251 IPs. You can also add a gateway subnet or virtual appliance subnet. So you can also see a diagram here. That's a network diagram. So this network diagram, on top of this, we can add VMs. So let's see how it looks after we add VMs, right? So let's create a virtual machine. The front end subnet will have so I'll say web VM1 is a virtual machine and it has to be in the same region as the VNET. So availability options, right now I can select a availability zone. That means within a region, you will have 3 availability zones. Availability set, distribute your VMs are from multiple fault domains. So if you have a planned maintenance, then you can do availability set. But right now, I will just go with let's select the availability set. Okay, and you have to create a new availability set called test AS. So just watch this, and in the next class we are going to discuss more about the fault domain, update domain, availability set, availability zone, and also virtual machine scale set. How all these availability options, high availability options. So first see that fault domain by default is 2, update domain by default is 5. Okay. So if you go, it's 3,800 rupees per month for one CPU standard storage, 3.5 GB. But if I go for spot instance, that means there's no guarantee of the uptime. Then it will come to less than $0.07 per hour. So spot instance you can use for a test or dev environment where it doesn't matter if the server comes down. So you see the price goes down uh, drastically. Right now, I'm not selecting spot instance. I'm just saying, and then you have to create a username password to log in, and you have to remember this. So by default 3389. I'm also going to turn on 80 and 443 for web server to connect. So it is showing premium SSD. If you go for standard, it will be cheaper, but web server standard is enough, right? So we'll go for standard storage. Default encryption. So the VM gets shut down, you get an email to my email address, and then so you can also have a proximity placement group, PPG. Right now, there's no proximity placement group, so we'll just leave it. So tags, you can write any tag, but I just leave it for now. And then I'll review and create. So I'm going to create two VMs in my front end subnet. So maybe I can also create a load balancer. Web VM1 is getting created. In the meantime, I'm going to create one more VM. Maybe same configuration as Web VM1. Web VM2. H2S. Windows Server 2012. I'll create the same availability set. HTTP, I'm going to turn on ports so people can connect through the internet. Check the disk, standard disk is enough. You can add, attach a new disk to this. So if you want to attach a new disk, attach an existing disk, that is always possible. So by default, you have a disk. So I'll just leave the default. But if you want to add more disk, you can always add more disk. One mistake I have done is I have not mentioned the subnet where it has to reside, right? This has to be in the front end subnet. Carefully select the front-end subnet, WebVM2, turn on the ports, one zero two four GB premium SSD LRS locally redundant. Let's see the network diagram. Network watcher. So if you see the front-end subnet WebVM2 has been created, it has a network interface card, it has a NSG and IP address. NSG has all these ports which we added. 80 is allow and 443 is allow. We created that. So that is inbound security rules. So for the WebVM2, there is an IP address which you can copy and you can RDP to that machine. Click on connect, the RDP will start, download and RDP. It will ask you the username, password which you gave during creation. Your user, and once you create it, make is the web's IIS server. So let's see the web VM1. What happened to web VM1? If you enable this port, the port's inbound rule will get added to the VM. Give some disk, get standard SSD. Continue this. So just review before you create WebVM1 East US. It has availability set. It's Windows Server 2012. RDP HTTP is configured. It is going to backend subnet, so that is something we have to change. It has to be front end subnet. You also gave the password, right? Because without the password, it won't work. The password has to match. So now you can review and create. Okay, everything looks good. Let's create. So if you see WebVM 2 got created, WebVM1, VNET, Subnet, everything got created. And also I installed IIS in WebVM 2. Let's see the topology network watcher now that both the VMs are got created. There you go. So in the backend subnet, I can create database and let's see load balancer. So name it as test load balancer east west. Add a front end IP. So load balancer IP. So we'll continue the load balancer availability group in the next class. So far you have seen how we calculate the range from a CIDR notation and how we divide the range into subnets. And also we have seen how we create a VNET VM and how we assign the VM to a subnet. And also you have seen how you can see the network watcher, the topology, right? So that's all for module 2. We will continue this in the next session uh, from where we stopped. I hope you enjoyed the session and hope you practice everything. And this is how your topology looks like right now. Okay, thank you very much.